We often think of strength in terms of the body, lifting weights, building muscle, but the brain operates under remarkably similar principles. It adapts to stress, it rewires through repetition, and most importantly, it grows when challenged and allowed to recover. This isn't metaphor, it's biology. The brain's capacity to change, known as neuroplasticity, is driven by how we engage with our environment. Every time we focus deeply on a task, especially one just beyond our current ability, we are signaling the brain to rewire. The key is deliberate, high-quality focus, short, intense intervals of mental work, free from distraction, paired with rest. But just like muscle recovery is essential for gains, cognitive recovery is non-negotiable. Deep sleep, especially slow-wave sleep, acts as the brain's anabolic window, where memories consolidate and synaptic connections strengthen. Controlled stressors, like cold exposure, time breathing, or challenging learning, create short bursts of neurochemical activity. These mimic the effect of lifting heavy mental weights. The result? Greater clarity, more resilience, sharper cognition. And finally, don't overlook the basics. Morning sunlight triggers cortisol rhythms that prime your brain for focus. Physical movement increases BDNF, a protein that acts like Miracle-Gro for neurons. Nutrients like omega-3s and magnesium, they're the fuel that powers this machinery. Train your brain like a muscle. The science is clear. Effort rewires the mind. What you do daily becomes who you are mentally. So start training just like our muscles respond to physical training by growing stronger. Our brain adapts to mental challenges through a process known as neuroplasticity. Neuroplasticity is the brain's ability to reorganize itself both in structure and function in response to experience, learning, and even injury. This capacity doesn't disappear after childhood, although it becomes more selective and effort-dependent over time. What drives neuroplasticity? Repetition, intensity, and relevance. When you engage in focused mental effort, like learning a new language, playing a musical instrument, or solving complex problems, the brain responds by strengthening the neural pathways associated with those tasks. Neurons that fire together wire together. This means that the more consistently and intentionally you activate specific circuits, the more robust those circuits become. It's like doing repetitions in the gym. Each round reinforces a muscle fiber. Each round of focused thought reinforces a synaptic connection. Crucially, the brain doesn't just grow through stimulation, it grows in response to challenge. Tasks that are slightly beyond your current ability are the sweet spot for neuroplasticity. When you're pushed just outside your comfort zone, your brain is forced to adapt, to create new connections and enhance existing ones. This is where real cognitive growth occurs. There's also a timing element. Neuroplasticity is most responsive when paired with high alertness states. When neuromodulators like acetylcholine and norepinephrine are released, these chemicals act like spotlight beams, telling the brain, this matters. Pay attention. Change here. That's why intentional focus combined with stakes or novelty can turbocharge learning and rewiring. However, plasticity is a double-edged sword. The brain also adapts to negative patterns like chronic distraction, stress, or inactivity. This means that what you repeatedly do, think, or feel actually shapes your brain's wiring over time, whether it's beneficial or not. You're always training your brain. The only question is, what are you training it to become? In short, neuroplasticity is not just a passive background process, it's your brain's active response to experience, effort, and attention. By understanding and leveraging this principle, you can consciously reshape your mental capabilities, expand your cognitive limits, and optimize how you think, learn, and perform. Just like training a muscle, it takes consistency, challenge, and rest, but the payoff is a brain that is sharper, faster, and more adaptable. Deliberate focus is one of the most powerful tools for building cognitive strength, and it works in much the same way as resistance training for the body. When you direct your full attention toward a task, especially one that is mentally demanding, you activate specific neural circuits with precision and intensity. Over time, this focused effort strengthens those pathways, enhancing your ability to think clearly, solve problems, and retain information. Focus isn't just about avoiding distractions, it's about engaging the brain in a way that signals importance. When you're locked into a challenging task, your brain releases neuromodulators like acetylcholine, which enhances signal transmission in active circuits. This chemical environment supports synaptic plasticity, the creation and reinforcement of connections between neurons. Simply put, deep concentration helps the brain decide what's worth keeping and strengthening. However, this kind of focus has to be deliberate. Passive attention, like casually browsing or multitasking, does not trigger the same neurobiological response. In fact, multitasking degrades the quality of focus and weakens cognitive control over time. Conversely, sustained single casting under effortful conditions builds cognitive endurance and clarity. It's the equivalent of doing high-quality reps at the mental gym. To make the most of deliberate focus, time and environment matter. The brain operates in ultradian cycles, roughly 90-minute waves of heightened alertness, followed by natural dips. Aligning deep work sessions with these peaks allows you to access optimal mental energy. Minimizing external distractions during this time, phones off, tabs closed, notifications silenced, creates the conditions for uninterrupted cognitive exertion. Additionally, the duration of focus should be manageable. Research shows that even 25 to 60 minutes of intense, uninterrupted focus followed by a short recovery window can yield significant improvements in mental performance. This practice, over weeks and months, builds the neural architecture for sustained attention and faster information processing. Over time, deliberate focus trains the prefrontal cortex, the brain region responsible for executive functions like planning, decision-making, and self-control. Like a muscle, it becomes stronger, more efficient, and more resistant to distraction the more you use it properly. In an age where attention is constantly under siege, deliberate focus is a superpower. It not only boosts productivity in the moment, but builds long-term cognitive strength that supports learning, memory, creativity, and resilience across every domain of life. REM sleep, the phase associated with vivid dreaming, is just as vital. It supports creativity, emotional processing, and problem solving by integrating disparate pieces of information in new ways. It's during REM that the brain reorganizes and reframes knowledge, forming connections that weren't obvious before. This explains why sometimes a solution to a problem appears after a good night's sleep. But recovery isn't only about sleep. Short periods of rest during the day, such as deep breathing, non-sleep, deep rest, NSDR protocols, or even brief naps, can significantly enhance learning and reset your ability to focus. These moments of intentional rest reduce cortisol levels, restore alertness, and prevent cognitive fatigue from building up. Neglecting rest disrupts this entire system. Chronic sleep deprivation impairs attention, memory, consolidation, and decision-making. Even moderate sleep loss, just a couple of hours per night, can significantly reduce brain performance over time. To optimize brain recovery, consistency matters. A regular sleep schedule, exposure to natural light in the morning, and limiting artificial light and stimulation in the evening all support the brain's internal clock or circadian rhythm, which governs the quality of rest and sleep. Nutrition, hydration, and physical activity also play a supportive role by regulating hormones that influence sleep cycles. Ultimately, if effort and focus are what build new neural connections, rest and sleep are what stabilize and strengthen them. They are not optional. They are the biological foundation that allows the brain to grow. Stress, when applied in measured doses, functions like a cognitive dumbbell. It challenges the brain, activates growth mechanisms, and builds resilience. While chronic stress is harmful and depletes mental resources, short bursts of controlled acute stress can enhance focus, memory, and adaptive capacity. The key lies in how much, how often, and under what conditions stress is experienced. When we encounter a stressor, like a challenging task, public speaking, or exposure to cold, the brain responds by releasing a cascade of neurochemicals, including adrenaline, norepinephrine, and cortisol. These chemicals heighten alertness, increase reaction speed, and enhance the brain's ability to encode information. In fact, some of the strongest memories we form are linked to moments of elevated stress precisely because of these neurochemical shifts. Tasks can serve as powerful tools to build mental toughness and enhance performance. These stressors should be time-limited, voluntary, and followed by recovery phases. This hormetic principle, where low doses of stress make you stronger, is well cemented in neuroscience. Mental framing also matters. Stress perceived as a challenge rather than a threat changes the body's physiological response. It shifts the hormonal profile toward growth and adaptation rather than damage and depletion. In moderation, stress acts as a training tool for the brain. Like resistance in physical training, it provides the tension needed for neural adaptation. When paired with rest and positive intent, stress becomes a catalyst, not an obstacle, for cognitive growth. The brain's ability to grow, adapt, and rewire, known as neuroplasticity, is not solely determined by mental activity. It is profoundly influenced by foundational lifestyle factors: nutrition, physical movement, and exposure to natural light. These elements don't just support brain health, they actively prime the nervous system to make and retain the very changes that cognitive training demands. Nutrition provides the raw materials for neuroplasticity. Omega-3 fatty acids, especially DHA, are critical components of neuronal membranes and support synaptic function. A deficiency in omega-3s impairs learning and memory, while supplementation has been shown to enhance cognitive performance. Similarly, micronutrients like magnesium, zinc, and B vitamins act as cofactors in neurotransmitter synthesis and energy metabolism. Without them, the brain lacks the biochemical support for growth and repair. Glucose is the brain's primary energy source, but stable blood sugar, not spikes or crashes, is essential for maintaining focus and synaptic. If diets high in processed sugars and low in nutrients can impair attention, increase inflammation, and even reduce the brain's ability to form new connections. In contrast, a diet rich in whole foods, healthy fats, and antioxidants fuels the cellular processes behind neuroplasticity. Movement is equally vital. Physical exercise, particularly aerobic activity, increases levels of brain derosive neurotrophic factor, BDNF, a key molecule involved in the creation of new neural pathways. BDNF essentially acts as growth fertilizer for the brain, enhancing learning, memory, and emotional resilience. Even moderate daily movement improves blood flow to the brain, delivering oxygen and nutrients that support cognitive function. Resistance training, too, has been linked to improvements in executive function and neurogenesis. Light exposure, especially early in the day, synchronizes the brain's internal circadian clock. Morning sunlight triggers the release of cortisol at the right time, boosting alertness and enhancing the brain's readiness to learn. Light also regulates melatonin production, which governs sleep quality, a critical component of memory consolidation and plasticity. Inadequate exposure to natural light or overexposure to artificial light at night can disrupt these rhythms and impair cognitive performance. These foundational elements, what you eat, how you move, and how your biology interacts with light, are not optional supports but direct contributors to the brain's capacity to change. When optimized, they create the ideal internal environment for focus, learning, and long-term neuroplastic gains.